December 14, 1972. Gene Cernan climbs back into the lunar module, brushes the dust off his suit, and becomes the last human being to stand on the moon. He says, "We leave as we came, and God willing, as we shall return." That was 53 years ago. We haven't been back. 53 years. The longest gap in human exploration since we figured out how to cross oceans. Longer than the gap between the Wright brothers and the jet engine. Longer than the gap between Sputnik and the space shuttle. But in April 2026, 4 people are about to change that. No landing, not yet. A loop around the moon and back, 10 days. But the first time humans leave Earth orbit in over half a century. Tonight, the story of Artemis II. The crew, the rocket, the 50 years we lost, and why going back turned out to be harder than going in the first place. Tonight on Stardrift FM. Here's what happened after Gene Cernan came home. Nothing. Apollo 18 was canceled. So were 19 and 20. Congress cut the budget. Vietnam was expensive. The public had lost interest. 12 men had walked on the moon and America shrugged and said, "We've been. Why go back?" The irony is painful. At that exact moment, December 1972, the United States had the most advanced lunar capability in history. Saturn V could throw 45 metric tons to the moon. The lunar module could land 2 people on the surface and bring them back. Mission Control had run 6 flawless landings in 3 years, and they chose to stop. Within a few years, the Saturn V production lines were shut down, the tooling was scrapped, the engineers retired or moved on. The country that landed on the moon literally could not do it anymore. Chose not to, could not. Then came the Space Shuttle, a magnificent machine, arguably the most complex vehicle ever built. It flew for 30 years, 1981 to 2011, 135 missions, built the International Space Station. And it went nowhere new. Low Earth orbit, 400 kilometers altitude. The moon is 384,000 kilometers away. The shuttle couldn't reach it. It was never designed to. Then came the promises. 1989, George H.W. Bush announces the Space Exploration Initiative, Moonbase, then Mars. Estimated cost, $500 billion. Congress takes one look and says no, program canceled. 2004, George W. Bush announces Constellation. Return to the moon by 2020. New rocket called Ares. Orion capsule. Development actually starts. 2010, Obama cancels Constellation. We've been to the moon. There's a lot more of space to explore. Pivots to a mission to redirect an asteroid. Nobody gets excited. Orion survives the cancellation. The capsule transfers to the next program. Ares dies. 2017, Trump signs Space Policy Directive 1, back to the moon, again. The Artemis program is born. 4 presidents, 4 programs, 50 years of promises. So when NASA said we're going back for the 4th time, nobody was sure they meant it. But this time, something was different. This time, they actually had a rocket. The Space Launch System, SLS, the most powerful rocket ever to fly. 8.8 million pounds of thrust at liftoff, 15% more than Saturn V, 322 feet tall, 5.7 million pounds sitting on the pad. Now here's the uncomfortable part. Saturn V was conceived in 1962, first flight 1967, moon landing 1969. 7 years from a blank page to boots on the lunar surface, 13 flights in 6 years. Cost per launch, about $1.5 billion, adjusted for inflation. SLS was authorized in 2011, built from the bones of the canceled Constellation program. First flight, 2022, 11 years to first uncrewed test. 1 flight in 4 years, cost per launch, $4.1 billion, nearly 3 times the price, a fraction of the flight rate, over a decade longer to develop. And a lot of the hardware isn't even new. The RS-25 engines at the base of the core stage. Those are Space Shuttle main engines, literally refurbished and reinstalled, each one producing 512,000 pounds of thrust. Proven, reliable, but expensive. And here's the difference. The shuttle recovered its engines after every flight. SLS drops them in the ocean, the solid rocket boosters. Shuttle design with an extra segment. 5 segments instead of 4. 3.6 million pounds of thrust per booster. There's a joke in aerospace. SLS is the shuttle without the reusability. In February 2026, NASA Administrator Jared Isaacman canceled SLS Block 1B, the planned upgrade with a more powerful upper stage called the Exploration Upper Stage. Boeing had the contract. Billions had already been spent. Isaacman's reasoning: it is needlessly complicated to alter the configuration of the SLS and Orion stack to undertake subsequent Artemis missions. Translation: stop upgrading, standardize, fly what we have more often. He also called SLS the lowest flight rate of any NASA-designed vehicle, which is both accurate and brutal. But here's the thing: it works. Artemis, I proved that in 2022, 25.5 days, around the moon and back, every system nominal. And right now, in March 2026, SLS is the only rocket that can send humans to the moon. There is no alternative, not yet. Saturn V was built in a decade of urgency. SLS was built in a decade of committee meetings. One was a sprint, the other is a marathon that nobody asked for. But they're both standing on Pad 39B, and they both go to the moon. The Orion spacecraft, the capsule that will carry 4 astronauts around the moon. Look at it. It's a cone, just like Apollo. 53 years of aerospace engineering, and the optimal shape for atmospheric re-entry is still a cone. Physics doesn't care about progress. The shape that works, works. But inside, completely different machine. Apollo Command Module, 6.2 cubic meters of habitable space, paper checklists, analog gauges, slide rules for backup calculations. 3 crew members in a space the size of a large car. Orion, 8.95 cubic meters. Glass cockpit with touchscreens. Fly-by-wire controls. Autonomous navigation. The spacecraft can bring the crew home without a single command from Houston if it has to. 4 crew members with roughly 50% more room. Apollo was designed for 14 days maximum. Orion is rated for 21 days undocked. Up to 6 months if docked to a space station. Same shape, different century. And then there's the part that makes this different from Apollo in a fundamental way. The European Service Module. Built by Airbus Defence and Space in Bremen, Germany. Over 150 engineers from 10 European countries. Provides propulsion, electrical power, water, thermal control, atmosphere, 33 engines. 4 solar array wings generating 11.2 kilowatts of electricity. Twice what Apollo managed. 50 years ago, going to the moon was an all-American project. Now it takes a continent. One more thing, the heat shield. If you watched our last episode, the dress rehearsal, you know what happened. Artemis I came back with its AV-sewed heat shield cracked in over 100 locations. Gases trapped inside the ablative material during re-entry, pressure buildup, charred pieces broke off. NASA spent 2 years investigating, found the root cause, insufficient permeability. The material couldn't vent gases fast enough during the skip re-entry profile. Their decision for Artemis II: don't replace the shield. Modify the re-entry trajectory instead. Change the angle, the timing, the profile. Eliminate the conditions that caused the cracking. Controversial, debated publicly, some engineers disagreed, external experts questioned it. But the data showed something important. A crew would have survived Artemis I's re-entry. The heat shield cracked, but it held. Temperatures inside stayed survivable. Future missions get a redesigned, more permeable AVCO8. But Artemis II flies with what it has on a different trajectory. They didn't fix the shield. They fixed the angle. And that might be the most NASA thing ever. Now, the people. This is the part that matters most. Not because the hardware isn't important, it is. But because the hardware exists to carry these 4 humans around the moon. And who they are says everything about how 50 years changed us. 12 men walked on the moon during Apollo, all white, all American, all military test pilots or engineers with military backgrounds. Crew cuts and square jaws and that particular brand of quiet confidence that came from flying experimental aircraft at Edwards Air Force Base. That was who astronaut meant in 1972. There was exactly one template and everyone fit it. Now look at the Artemis II crew. Reed Wiseman, commander, Navy test pilot, flew F-18 combat missions. ISS veteran, Expedition 41 in 2014. Served as NASA chief astronaut from 2020 to 2023, then stepped down to focus on Artemis II training. He's the closest to the Apollo mold, military pilot, command experience, square jaw, but even he represents change. He trained with international crews, served under the first female ISS commander, sees space as a collaborative project, not a competition. His job, lead 4 humans around the moon and bring them home. Victor Glover, pilot, Navy test pilot, FA-18 combat missions. Over 3,000 flight hours, 400 carrier landings. He flew on SpaceX Crew 1 in 2020, the first operational mission of Crew Dragon. Spent 167 days on the ISS. Conducted 4 spacewalks. And on Artemis II, he becomes the first black astronaut to fly beyond low Earth orbit, the first person of color to leave Earth's immediate neighborhood. 50 years ago, the astronaut corps had one template. Victor Glover broke it. Christina Koch, mission specialist, electrical engineer, worked at NASA Goddard Space Flight Center, Johns Hopkins Applied Physics Lab. Spent time at remote science stations in Antarctica and American Samoa before becoming an astronaut. Her ISS mission, Expedition 59 through 61, lasted 328 days, the longest single spaceflight by a woman, ever. She was part of the first all-female spacewalk with Jessica Meir on October 18, 2019. On Artemis II, she becomes the first woman to fly beyond low Earth orbit. Let that sink in. Valentina Tereshkova flew in 63 years ago. Sally Ride in 1983. Dozens of women have been to space since then, and not a single one has ever been farther than 400 kilometers from Earth. 53 years of spaceflight, and no woman has ever been this far from home. Christina Koch changes that. Jeremy Hansen, mission specialist, Canadian Space Agency, former CF-18 fighter pilot, member of the Canadian NORAD region, elected as an astronaut in 2009. 16 years of training. And here's the thing about Jeremy Hansen, Artemis II will be his first space flight. His first time in space is a trip around the moon. Most rookies get low Earth orbit. A few months on the ISS, Hansen gets the moon. He's also the first non-American to fly beyond low Earth orbit. Canada contributed $2.5 billion to the Artemis program and Canadarm30, the next generation of robotic arm for the Gateway Station. In return, they got a seat to the moon. Let's put the contrast in plain terms. Apollo 17, the last crew to go to the moon. December 1972. James Cernan, white, American, Navy pilot. Harrison Schmitt, white American, geologist. Ron Evans, white, American, Navy pilot. Artemis II, April 2026. Reed Wiseman, white American, Navy pilot. Victor Glover, black American, Navy pilot. Christina Koch, white American engineer. Jeremy Hansen, white Canadian Air Force pilot. Same moon, different world. We didn't go back for 50 years, and in those 50 years, we changed who means. So what are they actually going to do up there? The mission profile is called a free return trajectory. Here's what that means. Launch from Kennedy Space Center, Pad 39B, the same pad that launched Apollo missions. A few orbits around Earth for systems checkout. Then the trans-lunar injection burn, The ICPS upper stage fires one last time, pushing Orion out of Earth orbit and toward the moon. Then the upper stage separates. Orion is on its own. 4 days coasting to the moon. Closest approach, about 80 miles above the lunar surface. The crew will see craters, mountains, the permanently shadowed regions at the poles, with their own eyes, not on a screen, not through a camera feed, through the windows of a spacecraft 80 miles from another world. Then gravity does the rest. Orion looks behind the moon and the moon's gravity slings it back toward Earth. No orbital insertion needed, no braking burn. The trajectory is designed so that if everything fails, if every engine stops working, the moon's gravity alone sends them home. That's what free return means. The physics is your backup plan. 4 days back, re-entry with a modified skip profile, splashdown in the Pacific Ocean. 10 days total. Now, 50 years contrast. Apollo 8, December 1968. The first crewed flight to the moon. Frank Borman, Jim Lovell, Bill Anders. Apollo 8 was audacious. It was only the second crewed Apollo flight. Apollo 7 had been the first, just 2 months earlier. NASA decided to send humans to the moon in August 1968 and launch them in December. 4 months from decision to lunar orbit. No lunar module on board. No abort options beyond free return. They went because the CIA reported the Soviets might fly a cosmonaut around the moon first. 4 months of planning, and they sent 3 men to the moon. Artemis II is more cautious. It was preceded by a full uncrewed test, Artemis I, 25.5 days, every system validated. The heat shield was analyzed for 2 years after that test. The re-entry trajectory was redesigned. The mission was delayed multiple times to get it right. 4 years between the uncrewed test and the crewed flight. In 1968, NASA said, the Soviets might beat us and send 3 men around the moon with 4 months of planning. In 2026, NASA took 4 years after the uncrewed test to send a crew on the same trip. Neither approach is wrong. 1968 accepted risk that would be unthinkable today. 2026 has a caution that would have been unimaginable in the space race. We've changed how we think about the value of human life in spaceflight. That's not a bad thing. But it's a slow thing. What the crew will do during those 10 days, test life support with actual humans aboard. First time for Orion. Manual piloting near the moon. The crew takes hand-flying control to validate that humans can fly Orion manually in deep space. Deep space communications testing. Navigation system validation with crew input, photography, and observation. Only 24 humans have ever seen the far side of the moon with their own eyes. 4 more are about to join that list. October 20th, 2025. SLS stacking completed in the Vehicle Assembly Building at Kennedy Space Center. After months of assembly, solid rocket boosters, core stage, ICPS upper stage, Orion spacecraft, a 322-foot tower of hardware stands ready. January 18th, 2026. Rollout. The crawler transporter, the same vehicle that carried Saturn V rockets in the 60s, carries SLS to Launch Complex 39B. About 1 mile per hour. Takes several hours. Thousands of people watch. Then testing. February 2nd, 2026. Wet dress rehearsal number 1. Fill the rocket with cryogenic propellant. Run through the countdown. Stop just before ignition. It's a standard procedure. They did it for Artemis I too, multiple times. Problem: liquid hydrogen leak. Hydrogen is the smallest molecule in the universe. It leaks through seals, through welds, through materials that would stop anything else. This is a known problem with SLS. It happened repeatedly during Artemis I preparations. Result: launch window slips from February to March. February 19th, wet dress rehearsal number 2. This time, success. Full countdown rehearsal completed. Propellant loaded, systems tested, countdown executed, everything nominal. NASA eyes early March for launch, and then February 21st. Engineers are doing post-WDR transition work, preparing the rocket for actual launch, and they discover that helium isn't flowing properly into the upper stage. The ICPS. Helium is critical for this engine. It pressurizes the propellant tanks, purges lines, keeps the RL-10 engine ready to fire. Without helium flow, the upper stage can't function. Root cause: a misaligned seal in the quick disconnect mechanism. The interface between ground equipment and the rocket. A seal, a small piece of hardware in a $4 billion rocket, was slightly off, blocking the helium path. February 25th, rollback. The crawler transporter carries SLS back to the vehicle assembly building. Same slow trip, opposite direction. Seal replacement. Battery maintenance, inspections, new target no earlier than April 1st, 2026. 50 years contrast, Apollo had problems too. Apollo 12 was struck by lightning 36 seconds after liftoff. Twice. The spacecraft's electrical system scrambled. Telemetry went haywire. For a few seconds, nobody knew if the rocket was going to make it. Flight controller John Aaron, 26 years old, recognized the signature of a specific power supply mode and called out 3 words, SCE to AUX. The crew flipped a switch they barely knew existed. Systems came back. They kept going and landed on the moon 2 days later. Apollo 13. Oxygen tank explosion on the way to the moon. Houston, we've had a problem. 3 men, 200,000 miles from Earth, in a spacecraft that was failing. They never landed, but they came home. The difference isn't the problems. Rockets always have problems. The difference is the pace. NASA launched 9 crewed Apollo missions in 3 years, 1968 to 1972. 4 of them landed on the moon. Artemis has launched 1 uncrewed mission in 4 years, with a second still in the building getting a seal replaced. Every delay is a decision not to rush humans into danger, and that's the right instinct. But there's a difference between caution and slowness. And 50 years later, we're still figuring out which one we're practicing. February 27th, 2026. Kennedy Space Center. NASA Administrator Jared Isaacman holds a press conference. Isaacman is a different kind of NASA administrator. He's a tech entrepreneur. He commanded the Inspiration 4 mission, the first all-civilian orbital spaceflight, and the Polaris Dawn mission, which included the first commercial spacewalk. He's not a career bureaucrat or a politician. He's someone who has personally strapped into a SpaceX capsule and gone to space. And he announces the biggest restructuring of the Artemis program since it began. Here's what changed. Artemis III. This was supposed to be the mission. First woman and first person of color on the moon. The headline, the marketing, the promise. The entire reason the program was called Artemis, the twin sister of Apollo, the goddess who would bring women to the moon. That mission no longer exists, not as planned. Under the new plan, Artemis III launches in mid-2027, but not to the moon, to low Earth orbit. Orion will dock with 1 or both commercial landers, SpaceX's Starship HLS and Blue Origin's Blue Moon, in Earth orbit. Test the docking systems, test the spacesuits, prove the hardware works, then come home. No moon, no landing. A systems test. The mission that was supposed to be the culmination of the program is now a dress rehearsal for the dress rehearsal. The first moon landing moves to Artemis IV. Early 2028, 2 full years after Artemis II. NASA hopes for 2 landings in 2028 to Artemis IV and V1 per year after that. SLS Block 1B, the planned upgrade with the more powerful exploration upper stage, is canceled. Boeing's contract, billions spent. Done. Standardize on Block 1. Stop making the rocket more complicated. Fly more often with what works. Isaacman explicitly invokes Apollo 9 as the precedent. Apollo 9, March 1969. 3 astronauts in Earth orbit. They tested the lunar module for the first time with a crew. No moon trip, just orbit. Prove the lander works before you trust it to land. 4 months later, Apollo 11 landed on the moon. Artemis III is being positioned as the Apollo 9 moment. Test the landers in orbit, prove they work, then land. But here's the 50 years contrast. Apollo went from first crewed flight, Apollo 7, October 1968, to moon landing. Apollo 11, July 1969, in 9 months. 9 months. 4 missions. Artemis first crewed flight, Artemis II, April 2026 to first landing, Artemis IV, early 2028, about 2 years. 1 intermediate mission. Slower, but also Apollo's pace was driven by Cold War urgency and a culture that accepted enormous risk. The Apollo 1 fire took 3 lives on the launch pad. NASA pushed through it in 18 months and flew again. Nobody wants to go back to that calculus. NASA's own Aerospace Safety Advisory Panel, ASAP, had publicly called the original 2028 landing plan unrealistic and too risky. That's NASA's safety people telling NASA leadership that their plan was unsafe. That's when you know something needed to change. One more thing Isaacman didn't mention in the press conference: Gateway. The Gateway, the planned space station in lunar orbit, was conspicuously absent from the announcement. Congress funded it, $2.6 billion. ESA says they'll build their modules. Canada is building Canadarm3 for it. But Isaacman's leaked policy blueprint, a 62-page document called Project Athena, explored replacing Gateway entirely, repurposing the hardware, building a moon base instead. The most expensive thing nobody is talking about. Isaacman's summary of the overhaul: we've got to get back to basics. While NASA restructures, delays, debates, and overhauls, someone else is building. China's lunar program. Let's go through the scorecard. Chang'e 1, 2007, lunar orbiter, mapped the entire moon, mission accomplished. Chang'e 2, 2010, high-resolution mapping, extended mission to an asteroid flyby, accomplished. Chang'e 3, 2013, first Chinese lunar lander, U-2 rover, accomplished. Chang'e 4, 2019, first ever landing on the far side of the moon. No nation had ever done it. China did it on the first try. Accomplished. Chang'e 5, 2020, sample returned from the near side. Brought back 1.73 kilograms of lunar soil. Accomplished. Chang'e 6, 2024, sample return from the far side. The first time any nation has returned samples from the moon's far side. Accomplished. 6 missions, 6 successes, no cancellations, no restructurings, no 5 different programs across 4 presidents. And here's what's coming. Chang'e 7, August 2026, South Pole scouting mission, orbiter, lander, mini-hopping probe, rover, looking for water ice in permanently shadowed craters. The same water ice that Artemis wants to find. The same South Pole that Artemis IV wants to land on. Chang'e 8, 2028, in situ resource utilization tests, extracting resources from the lunar surface, 3D printing with regolith, testing construction techniques for a permanent base, crewed lunar landing, target 2030, Long March 10 rocket, a brand new heavy lift launcher, Mengzhou crew vehicle, Lanyue lander, all in active development, all key tests completed or on schedule, on track. Now, 50 years contrast. In 1972, the race was over. America had won. The Soviet Union never landed a human on the moon. And America lost interest because there was nobody left to beat. That's the uncomfortable truth about Apollo. The moment there was no competitor, the funding vanished. In 2026, the race is back, but the competitor is different. The Soviet Union collapsed under its own weight. China is building. And there's a crucial difference in how they operate. China doesn't cancel programs mid-development. They don't have midterm elections that shift priorities every 2 years. They don't swap out their space agency leadership with every new administration. They pick a plan and they execute it. America has had 5 different moon programs since 1989. China has had 1, and China's is on schedule. there's a bigger picture here. Artemis Accords, 61 nations, US-led. A framework for how to explore space peacefully. Who can extract resources, how to protect heritage sites, how to share data. International Lunar Research Station, 13 nations. China-led, Russia, Pakistan, Belarus, South Africa, and others. Their own framework, their own rules. 2 competing visions for who makes the rules on the moon. 2 sets of international partnerships. 2 infrastructure plans. The math is simple. Artemis, first moon landing 2028 if it doesn't slip. China crewed landing 2030, on track. 2-year gap. Sounds comfortable. But Artemis has slipped from 2024 to 2024 to 2026 to 2028. Every single time, it moved later. If it slips once more to 2029 or 2030, the race becomes a tie. Or worse. This isn't about flags anymore. It's about who builds the infrastructure, who writes the rules, who gets to say how the moon is used. And right now, one side is executing while the other side is restructuring. 1972, last human on the moon. The counter starts. 1980, Saturn V production shut down. We can't go back even if we wanted to. 1989, a president promises the moon. Program canceled. 2000, the ISS, extraordinary, but still low Earth orbit. 2004, another promise. Constellation, canceled. 2010, we've been to the moon, redirect asteroids. 2017, Artemis born, 4th attempt. 2022, Artemis I, the uncrewed test, it worked. The ship came back empty. 2026, the counter reaches 53. 53 years of not going to the moon, but not 53 years of nothing. We built the space shuttle. We built the ISS. We launched Hubble and James Webb. We landed rovers on Mars. We sent probes past the edge of the solar system. We discovered thousands of exoplanets. We photographed a black hole. We did extraordinary things. We just didn't go back. But now a rocket in the vehicle assembly building, getting a seal replaced, a crew in training, a launch window in April. No landing yet, just a loop, 10 days, 80 miles above the lunar surface. But the first time in over 50 years, the crew isn't all white American men anymore. It's a black Navy pilot, a woman who spent 328 days in space, a Canadian fighter pilot who's never been to space before, and a commander who gave up his desk job to fly this mission. The spacecraft isn't all American anymore. Europeans built half of it. The mission isn't about beating someone anymore. It's about building something sustainable, setting up camp, learning to stay. Or at least, that's the plan. If the schedule holds, if the hardware works, if the politics don't shift again, if the next president doesn't cancel it like the last 4 programs. We changed a lot in 50 years. We changed who gets to go. We changed how we build. We changed why we go. We changed the rules, the partners, the politics, and the price tag. The one thing we haven't changed is how it feels to look up at the moon and wonder what it's like to stand there. 4 people are about to find out what 50 years of wondering looks like from 80 miles above the surface. This is Stardrift FM. Keep drifting.